Welcome to this lesson on normal force, part of our forces series. Normal force is one of the most common forces we encounter in everyday life. It's the support force that surfaces exert on objects resting on them. Let's explore what makes this force so important in physics. Normal force is a contact force exerted by a surface on an object, and it always acts perpendicular to that surface. The word normal in physics means perpendicular or at 90 degrees to the surface. This is a crucial characteristic. Normal force always pushes away from the surface and never pulls toward it. This makes sense because a surface can only push an object away, not pull it in. Let's look at the key characteristics of normal force. First, it's always perpendicular, acting at 90 degrees to the contact surface. Second, it's a contact force, meaning it only exists when two surfaces are actually touching each other. Third, normal force is reactive. It adjusts its magnitude automatically to prevent the object from passing through the surface. And finally, it can only push, never pull. Surfaces physically cannot exert a pulling force on objects. Normal force is all around us. When a book rests on a table, the table pushes upward on the book, balancing its weight. When you're standing on the floor exerts an upward force preventing you from sinking through it. A car on a road experiences the road surface pushing up perpendicular to the ground. Even a picture hanging on a wall experiences normal force as the wall pushes outward perpendicular to its surface. These everyday situations all involve normal force at work. On a horizontal surface with no tilt, calculating normal force is straightforward. When an object is at rest with no additional vertical forces acting on it, the normal force equals the weight of the object. Mathematically, normal force N equals mass m times gravitational acceleration, g. This makes intuitive sense. The surface must push up with exactly enough force to balance the object's weight, keeping it in equilibrium. This is the simplest case of normal force. Things get more interesting when we consider inclined planes, or ramps. On an incline, the normal force is still perpendicular to the surface, but now the surface itself is tilted. This means the normal force is no longer vertical. Here's a key insight. The normal force on an inclined plane is actually less than the object's weight. This happens because only a component of the weight acts perpendicular to the surface, while the rest acts parallel to it, trying to slide the object down the incline. The formula for normal force on an inclined plane is N equals mg cosine theta. Here, N is the normal force perpendicular to the surface. M is the mass of the object, and g is the acceleration due to gravity, which is 9.8 meters per second squared. Theta is the angle of the incline measured from the horizontal. The cosine function accounts for the fact that only part of the weight acts perpendicular to the inclined surface. As the angle increases, the normal force decreases. Normal force can change when additional vertical forces are applied. If you push down on an object, the normal force increases. The formula becomes N equals mg plus F, where F is the additional downward force. The surface has to push harder to support both the weight and the extra force. Conversely, if you pull upward on an object, the normal force decreases. The formula becomes N equals mg minus F. The surface doesn't need to push as hard, because the upward pull reduces the effective load on the surface. Let's recap the key takeaways. First, normal force is always perpendicular to the contact surface. Second, it's a reactive force that automatically adjusts to prevent objects from penetrating through surfaces. Third, on horizontal surfaces, normal force equals mg when there are no other vertical forces. Fourth, on inclined planes, normal force equals mg cosine theta, which is less than the object's weight. And finally, additional forces like pushing or pulling can change the magnitude of normal force. Normal force truly is the surface support champion, always working to keep objects properly supported.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.